Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is continuity and differentiability. In this video we will be focusing on NCERT solutions for exercise number 3. In the first problem we need to find dy by dx for this function. Now you observe that y is not put explicitly as a function of x, means y equal to f of x is an explicit function, but this is an implicit function where x and y are mixed together. So how do we proceed? We find the derivatives where x is there, because with respect to x here normal derivatives will do, but what happens wherever y term is there, we'll find its derivative, then add a term dy by dx along with that. So let's proceed. So derivative of 2x will be 2. What is derivative of 3 into y? Derivative of y is 1. So 3 into 1, but y is there, so we'll add the term dy by dx equal to sin x derivative is cos x. So we'll keep the other terms there. Dy by dx will be cos x minus 2. So dy by dx will be cos x minus 2 divided by 3. Now we got another question where y term is there on both sides and we need to find dy by dx. So again we proceed. Derivative of 2x is 2 plus 3 dy by dx. Derivative of sin y is cos y, but y term is there, so we add dy by dx. Now we take all dy by dx together. So dy by dx cos y minus 3 will be equal to 2. Dy by dx will be equal to 2 by cos y minus 3. This is the final answer. Now in this problem again we follow the implicit rule. So first we find derivative of ax, which is a. Next we find derivative of b into y square. Y square derivative is 2y. So this will be 2by. Since y is there, we add the term dy by dx equal to cos y, derivative is minus sin y, into dy by dx. So we can combine the dy by dx term. So we can write 2by dy by dx plus sin y dy by dx equal to minus a. So we can write dy by dx 2by plus sin y equal to minus a, or dy by dx equal to minus a by 2by plus sin y. Now we have a combined x and y terms, but our procedure remains same. So what is the procedure for function with multiplication is done? First function into derivative of second function. So dy by dx. We are finding derivative of this first. So first function into derivative of second function plus second function into derivative of first function. Derivative of x is 1. Now we find derivative of x square. So that is 2y dy by dx equal tan x derivative is x square x plus derivative of y is dy by dx. So we combined all the terms of dy by dx. We can combine. So we can write dy by dx x plus 2y minus 1 equal to x square x minus y. So dy by dx equal to 6 square x minus y divided by x plus 2y minus 1. So this is the answer. And we can use product rule here. So derivative of x square is 2x. Derivative of xy is first function into derivative of y, which is dy by dx, plus y into derivative of x is 1. plus 2y dy by dx equal to derivative of a constant is 0. So we can write this as dy by dx x plus 2y. So we can take this outside, minus 2x plus y. So dy by dx will be minus 2x plus y divided by x plus 2y. So again we see an implicit function here. So we will find the derivative as earlier. So derivative of x cube is 3x square. Derivative of x square y is plus x square into dy by dx plus y into 2x. What is derivative of this? Plus x into 2y dy by dx plus y square plus 3y square dy by dx equal to 0. Derivative of 81 or any constant is 0. So we will combine all the terms of dy by dx. So we can write dy by dx x square, this term, then 2xy plus 2xy plus 3y square. So we combine these three terms. So the balance terms we can take it on the RHS, minus 3x square, this one, minus 2xy is this one, and minus y square. So we can get dy by dx as minus 3x square plus 2xy plus y square divided by x square plus 2xy plus 3y square. So what is derivative of sine square y can be written as sine y the whole square. So its derivative is dy by dx 2 sine y cos y into dy by dx. So now we'll add here that term. So this is 2 sine y cos y is sine 2y dy by dx. What is the derivative of this? Minus sine xy into derivative of xy. What is derivative of xy is x into dy by dx plus y. So we got two expression here. So we will combine the dy by dx term. So dy by dx will come here. So dy by dx will be sine 2y and minus x sine xy. We put a square bracket here. And one other term without dy by dx will be y and this. So we'll take it on the right side, y sine xy. So we got this. So we can put dy by dx equal to y sine xy divided by sine 2y minus x sine xy. This is the derivative. So this we can do easily again. So derivative of sine square x is 2 sine x cos x. What is derivative of cos square y? 2 cos y. Derivative of cos y is minus sine y. Y term is there, so we add dy by dx. And derivative of constant is 0. So we can take it on the other side. So dy by dx equal to 2 sin x cos x divided by 2 sin y cos y. This is sin 2x by sin 2y. This is the dy by dx. Now in this problem we have an inverse trigonometric function. So how do we proceed with that? So we see x term here and sine inverse term here. So we'll put a term such that the sine inverse gets cancelled with the some sine term here. So how do we proceed? We put x equal to tan theta. So this becomes y equal to sine inverse 2 tan theta divided by 1 plus 2 tan square theta. But what is this 2 tan theta by 1 plus 2? That is sine 2 theta. So this is sine inverse sine 2 theta. So y is equal to 2 theta. But theta is tan inverse x, 2 tan inverse x. So now we can find y derivative with respect to x. What is the derivative of tan inverse x is 1 by 1 plus x square. So dy by dx is equal to 2 by 1 plus x square. Now again in this problem we got a tan inverse and some function here. Again we put this x equal to tan theta here. So what y becomes tan inverse 3 tan theta minus tan cube theta 1 minus 3 tan square theta. But what is this expression? This is nothing but tan 3 theta. So this is tan inverse tan 3 theta. So this will go, we will get y equal to 3 theta. But theta is tan inverse x from here. So y equal to 3 tan inverse x. So what is dy by dx? Derivative of tan inverse x is 1 by 1 plus x square. So this is 3 by 1 plus x square. Now in this problem we have y equal to cos inverse 1 minus x square by 1 plus x square. Here also we put substitute, put x equal to tan theta. So what will be y? Y equal to cos inverse 1 minus tan square theta by 1 plus tan square theta. But what is this? This is cos 2 theta. This term is cos 2 theta equal to cos inverse cos 2 theta. So y will be 2 theta. But what is theta equal to? Tan inverse x from here. So y equal to 2 tan inverse x. What is derivative of tan inverse x is 1 by 1 plus x square. So dy by dx is equal to 2 by 1 plus x square. In this problem we need to find dy by dx for the sine inverse function. So what shall we do? What shall we put here? Again we put x equal to tan theta. Y equal to sine inverse 1 minus tan square theta by 1 plus tan square theta. Previously we have seen this is cos 2 theta. So we can write sine inverse cos 2 theta. But we want this to be in terms of sine so that it gets cancelled with this. So how do we put? Y equal to sine inverse sine 90 minus theta. So sine 90 minus 2 theta is cos 2 theta. Now we can cancel these two. So y equal to pi by 2 minus 2 theta, which can be written as pi by 2 minus 2 tan inverse x. Theta is tan inverse x. So we can find dy by dx, derivative of constant is 0 minus 2 by 1 plus x square. So this is the answer. Minus 2 by 1 plus x square. Now in this we want to find y equal to cos inverse 2x by 1 plus square dy by dx we want to find. So how do we proceed? What substitution we'll make? We'll again make y equal to tan theta. What is this? This is sin 2 theta. Cos inverse sin 2 theta. What we want here cos term. So we will put y equal to cos inverse cos 90 minus theta 2 theta. Cos 90 minus 2 theta is sin 2 theta here. So this can be written as y equal to pi by 2 minus 2 theta, or y equal to pi by 2 minus 2 tan inverse x. Dy by dx is, derivative of this is 0, constant is 0, so we will get minus 2 by 1 plus x square. So in this problem we have y equal to this function and we need to find dy by x. Whenever we see 1 minus x square square root, we substitute y equal to either sin theta or cos theta. We put x equal to sin theta here. So y equal to sin inverse is 1 minus sin square theta is cos square theta. Square root of that is cos theta. So sin inverse 2 sin theta cos theta. This is sin 2 theta. So this y will be equal to 2 theta. Y equal to 2 sin inverse x. Because x equal to sin theta, theta will be sin inverse x. What is the derivative of sin inverse x? 1 by square root of 1 minus x square. So dy by dx equal to 2 by square root of 1 minus x square. Now y equal to sec inverse this, we want to find the derivative. Now sec inverse we have to convert the bracket term to some secant function. That is difficult. So we do it another way. We can write this as sec y equal to 1 by 2x square minus 1. What is sec y? 1 over cos y equal to 1 by 2x square minus 1, or cos y equal to 2x square minus 1, or y equal to cos inverse 2x square minus 1. Now we can put x equal to cos theta. Put x equal to cos theta. So y will be equal to cos inverse 2 cos square theta minus 1. But what is 2 cos square theta minus 1? This is cos 2 theta. Cos inverse cos 2 theta, which is 2 theta. So y equal to theta is cos inverse x. So y equal to 2 cos inverse x. Derivative of cos inverse x is minus 1 by square root of 1 minus x square. So dy by dx will be minus 2 by square root of 1 minus x square. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.